I'm now going to start looking at camera lenses. Modern lenses are marvels of science and technology, and they come in a vast range of designs to cater for everything that we need. We've got wide-angle lens, telephoto lenses, macro, some tilt and shift type lenses, fisheye, zoom lenses. There's a whole range of lenses available to cater for everything that we need to take our photographs. So why do we need lenses and what are their properties? So they're fundamental to everything we do in photography. Without the lens we couldn't actually take the picture. So I'm going to take us through why we need lenses, how they work, their properties, and how we can make best use of them in our photography. And this will be over a series of videos. And lens apertures are part of our exposure triangle. Now we saw this at the start of this in the video on shutter speeds, and later on in subsequent videos we'll have a look at how the lenses and aperture fits into the exposure triangle. So how does a lens work? Now in other parts of the book that I produced I cover the properties of light in more detail, but basically as light passes through different mediums it changes speed, and as it does so it refracts, it changes direction at the point of where it enters or exits the different medium, whether it be air, glass, plastic, whatever transparent medium it passes through. So a lens can be made to refract light from a scene and bring it into sharp focus on a surface, and in our case it's going to be the digital sensor. Now each individual small area of the scene, in this case it's a red kite, is giving off light in all directions, and some of that light is heading towards our camera lens, and it's hitting the camera lens all across the front surface, the objective lens. Okay, so from each individual little spot on the scene, all over the place this light is being given off or reflected, and some of it from that one particular spot on the scene is going up there, across here, down here. So there's a whole load of little light particles from that one particular spot heading to our lens, and it then gets refracted and bent so that they all appear at one particular spot on the sensor. So here's our light cone, which I introduced in an earlier video. Okay, so it's not just one little part of light, it's loads and loads of little particles of light heading towards our lens from that one spot on the scene, on all coming together into one spot on the sensor to give you one little part of the image. So this light cone of light represents just one spot of detail from the subject, but similar cones could be drawn from every other part of the scene, building up to produce the full image. We generally tend to draw these cones of light for just one particular part for drawing simplicity. Now in this next one, this next slide, we can see the cone of light drawn from the tip, the wingtip of the red kite. In this case, you can see all the little particles of light from that one particular spot all heading towards the lens, and they all come to focus in a different part of the sensor, which will be the wingtip of the red kite on the sensor there. Okay, so that is happening to every single part of that scene, and it's building up the image simultaneously in a fraction of a second during that exposure time. Now we normally show a picture of a lens as a simple lens just for illustrating purposes, but modern lenses are comprised of literally a dozen or more elements, glass elements. So you've got glass, air, glass, air, glass, glass, air, glass, glass, air. So a whole different arrangement of how light can come into the lens and be refracted and guided through the lens onto the sensor. And the reason we have all this is because there are loads of different types of optical anomalies that need to be corrected. Now, we don't really need to know all this, but it's useful just to be aware this is why we have such complex lenses. We have chromatic aberration, where the different frequencies of light come to focus at different parts or different distances from the back of the lens. So this is where if we're focusing on the green part of the light, you'd have red light and blue light out of focus. Okay, so that would be chromatic aberration, and so the lenses are constructed to try and prevent that happening so that all colors of light get focused on the same plane. We've got coma, where we get outer distinct shapes, droplets like this. There's loads of other different types of optical anomalies that modern lenses have to contend with. And of course, as soon as you start introducing a zoom lens, as depicted here, we have to correct for all these anomalies at all the different focal lengths, which is why lenses become so complicated and indeed expensive. So hopefully that's given you a basic idea of how lenses are constructed and how they work.